Hello everyone. Today I am going to discussing about the basics of CNC part programming. Let's see what is the CNC part programming. It is the processing the instructions are documented on a form, which means all the instructions, for example, change the tool or coolant on or increasing the cutting speed and tool feed. These all instructions are documented on a form is calling as a part programming. Or all the instructions are given by the combination of letters and numbers, or we are calling as a part programming. So this all the instructions are giving in the form of block. Here block is nothing that it is a one step. So we have to execute the program by step. So here also we are giving the instructions by block we are giving. See here, these are the examples for the block. Here you have to observe that one. We are giving the all the instructions block by block we are giving. Here, block also having the certain format. That format is always start with capital N. That is the sequence number. Next, capital G. That is the geometry codes or preparatory functions. Next is XYZ. So this is the dimensions word. Next, capital F. That is the feed function. Next is capital S, that is the spindle speed. Next is capital T, that is the tool function. Next, capital M, that is the miscellaneous functions. Last one is EOB, which means end of the block. So first we will discuss about the sequence number, that is capital N. So generally it is used to identify the each block in the CNC program. So it appears the 3 digits after the capital N symbol. For example, N01, which means block number is 10. These numbers are always in the ascending order. For example, first one is the 10th block and next one is the 11th block. So next we will be discuss about the preparatory functions or maybe G codes. So this is generally denoted by capital G. These are associated with the movement of a machine axis and the associated with the geometry. These geometry codes are little different for the milling and turning operations. Moreover, here milling and drilling operations G codes are having the same. First, we will discuss about the G codes for drilling and milling operation. Here, tool will move in Z direction and table will be moved in X and Y directions. So, depth of cut is giving in Z direction, that is for the tool, and tool path, tool movement will be given by table movement, that is X and Y directions. In this, first we will be discuss about the motion group. Motion group codes are used to movement of table with respect to the tool path. First one is G00, that is for rapid positioning. If the tool is moving from one position to another position, so rapidly without any material removal condition. For this condition, we are using the G00 code for rapid positioning of the tool. And G01 is using for the linear interpolation, which means if the tool to be moved in linearly, which means horizontally, vertically or inclinedly. For this, we are using the G01 code. And G02 code is using for the tool to be moved in circular interpolation in clockwise direction. For example, tool movement is arc type in clockwise direction. We are using this code. And G03 code is using for circular interpolation in anti-clockwise direction. Next one is the dwell, which means stop the machine certain time for inspection purpose. And next one is the cutter compensation group. Miller cutter having the certain dimensions. So before start the part programming, we have to execute these cutter dimensions. For this, G40 code is using for the cutter compensation cancel, and G41 is using for considering the cutter compensation in left side, and G42 is using for considering cutter compensation in right side. And next one is units group. If we are following the units in inch using the G70 code and following the units in metric using the G71 code. And next one is the hole making carried cycle group. For hole making operations such as drilling, tapping and reaming and etc. These hole making operations are involved the repeated operations. First one is J80 is represent the Carnot cycle of, and G81 represents the type of hole making operations and on the Carnot cycle. Next one is coordinate system group. First one is the G90. G90 code is using for absolute coordinate system, and G91 is using for the incremental coordinate system. Last one is G92. It is used for preset the datum position. Next I will discuss about the coordinate system group, that is G90 and G91 codes. G90 is using for input of dimensional information can be done in absolute coordinate system, and G91 is using for input of dimensional information can be done in incremental system. So this is I will be discuss with one example. In the figure, tool has to be moved from O to C position. That is, tool root is O, A, B, C. The position of O is 0, 0. The position of A is 5, 10. The position of B is 25, 15. And the position of C is 35, 5 with respect to the X and Y axis. First we will see how to write the codes by using the absolute coordinate system. See, in absolute coordinate system, every point coordinates are taken from the reference point, that is 0, 0. So for the A point coordinates are here 5, 0, B point coordinates are 25, 15 and C point coordinates are 35, 5. Let's see, in the first block is represents the tool has to be moved O to A position linearly. So first block is N001, G90, G01, X5, Y10 and feed rate is 200. Here G90 is representing the absolute coordinate system and G01 is representing the tool has to be moved linearly, that is linear interpolation, and X5 and Y10 is represent the final position of the point A. So here tool has to be moved from O to A position. So in absolute coordinate system we have to write down the A coordinates with reference to the O coordinates. So O coordinates are 0, 0 and A coordinates are the 5, 10. So we have to represent the A point coordinates 5, 10 and feed is 200. So now tool is at position A, then we have to see how to write the code for the tool has to be moved from A to B. So that is N002, X25, Y15. Which is second block is representing tool has to be moved from A to B position, that is linearly, and here we are taking the coordinate system is absolute coordinate system. Here you have to note down that one. No need to separately mention once again G90 and G01. It is automatically take from the previous block. So I am writing the second block is N002, X25 and Y15. So tool has to be moved A to B position. So write down the B position, that is have to take reference point of the 00. So B position is with respect to O position is that is 25 and 15. So have to mention the x equal to 25, y equal to 15. So next block is tool has to be moved from B to C position. So tool has to be moved linearly from position B to C. So now my third block is N003, X 35.0, Y 5.0. See here, I am writing the C position with reference to the O position. So C positions are 35 and 5 with respect to X and Y axis. Next we will see the how to write the code in increment coordinate system for tool path OABC. In incremental coordinate system, tool location is taken by with respect to the previous location. Let's see the first block is movement of tool from O to A. See here, first block is N001, G91, which represents the, here we are taking the coordinate system is incremental coordinate system. Next one is G01, tool has to be moved linearly and 5, X is 5.0, Y is 10.0, mean tool has to be moved 0 to A position. So I have to write down the A coordinates with reference to the previous location. My previous location is here, O coordinates are 0, 0. So then A coordinates are 5, 10. So the difference is 0, 0 to 5, 10. The difference is 5 and 10. So here that's why I mentioned the first block is N001, G91, G01, X5, Y10 and feed rate is 200. Next tool has to be moved from A to B position linearly with incremental coordinate system. Here my second block is N002, X20 and Y 5.0. Here no need to mention the G91 and G01 and F200. It will be taken automatically from the previous block. See, have to observe here. So here I mentioned the X20 and Y 5.0. Now my tool position is at A and have to move tool linearly should have to move and reach to B coordinate, B point. So B point coordinates are the 25 and 15. A point coordinates are 5, 10. So the difference between the A and B is it should be 20 and the 5. So tool has to be moved A to B. A point coordinates are the 5, 10. B point coordinates are the 25, 15. So in the incremental system, B position will be taken from the previous position, that is point A. So the difference between the A and B, it will become the 25 and 5. So that's why here I have written the second block is N002, X20 and Y 5.0. Next now, tool is at B position, then tool has to be moved from B to C. Let's see how to write the for this one tool movement from B to C with linearly. So this is I represent in the third block, that is N0G3, X10 and Y minus 10. Here tool has to be moved from B to C position, which is linearly, that is mentioned in G01 in the previous block. And here we are following the incremental coordinate system, that is G91, that is also mentioned in previous block. See, in incremental coordinate system, the position is taken from the previous position. Here tool has to be reached at point C with reference to the point B. So point B coordinates are the 25, 15. Point C coordinates are the 35, 15. So the difference between the coordinates of the point C and the point B, it is the 35 minus 25. So that is the 10. And here 5 minus 15. That is the minus 10. See here minus 10. Next we will see the motion group G00, G01, G02 and G03 codes. First we will discuss about the G00 code, that is for rapid positioning. When the tool has to be moved rapidly from one position to another position, we are using this code. Generally, this code will be used in no material removal condition. Let's see the figure. Tool has to be moved from A position to B position rapidly. So the code is N001, G90, G00, X150 and Y30. Here following the absolute coordinate system, so write the G90 code and write the B coordinates, that is 150 and 30. Next discussing about the G01 code, which is linear or straight line positioning. This code is using when the material is to be cut using feed rate along a straight line. Let's see the example. For this code, for this my code is N G01, G90, G01, X150 and Y50 F200. Here note that when using the G01, G02 and G03 codes, write the feed rate, that is here F200. Next to see the circular interpolation, that is G02, G03. These codes are used when the arc is to be transverse in a plane. G02 is using when the direction of motion is clockwise and G03 is using when the direction of motion is anti-clockwise. So this is the way to write the code by using the G02 and G03 code. Here first one is directions, which means tool motion is clockwise or anti-clockwise. Based on direction in use the G02 or G03 code. Second one is final position of the point. And third one is radius of the arc or distance from the arc center to the initial position. Last one is speed. So next let's see the example. Here tool is moved like arc from A to B position. So our code will N001, G02. I am taking clockwise direction, so here writing the code is G02. And second one is the final position. Here my final position is the point B. So what are the coordinates of the point B is 65 and 60. So next I am writing after the G02, I am writing X65 and Y60. Next one is the R45. Here R45 is represent the radius of the arc and F200 it is represent the feed rate. So this code also you have to write in this way, another way. So that is NG01, G02, X65, Y60, I35, J-10, F200. Here I and J represents the distance from the arc center to initial position. So next to see the G04 code, that is dwell. This is used to give a delay in a program. Here X 4.0 represents the delay the program 4 seconds. Next we will see the M codes. Generally M codes are used for control the machine tool, and one more thing here we have to note down. So only one M code should be write in a single block. So these are the M codes. This you should have to remember. M03 represent the spindle move in clockwise direction. M03 represents the spindle move in counterclockwise direction. M05 represents the spindle stop. M06 is the tool change. M07 is for the coolant on. M08 also coolant on. So M07 is coolant 1 on. M08 is coolant 2 on. M09 is the coolant off and M30 is the end of the tape. So thank you.